Welcome back to math. Today we're doing Module 4, Lesson 23. We're comparing the size of the product to the size of the factors. So let's just do a little quick review. If I said I have 1 here and I equal some kind of fraction, what would it be? Well, you could say it's 2 over 2. That would be fine. Or you could say it's 3 over 3. Or you could say it's 99 over 99, right? Those are all ones. When you have the bottom number the same as the top number, it is a whole number. Also, we talked about if we have an 8 here, and we're going to multiply it by a fraction. We're going to multiply it by a fraction and make it equal to 8. What would this have to be? This would have to be 2 over 2, or 3 over 3, and 8 over 8, whatever you want to make it, right? Okay. What if I wanted to make this greater than this 8? What would I have to do to this side? I would have to have something that is, what? Bigger than the 2, right? Like a 3 over 2. This is bigger than 1 whole. So that means that it's going to be bigger or greater than 8. What if I want to make this 8 times a fraction less than this 8? What would I need over here? Well, yes, I could have a 1/2, right? What's 1/2 of 8? It's 4, right? So 4 is less than 8. So I need you to start seeing that when we have a fraction that's a 1, it's equal to that. If we have a fraction that is bigger or greater than 1, it's greater. And if we have a fraction that the number on the top is smaller than the one on the bottom, it's going to make this 8 smaller than that, or less than. Let's get going on our problem. Sort the following expressions by rewriting them in the table. This product is less than the boxed number. So we want the product is less than the box number. The product is greater than the box number. Now what's our box number here? It's 12.5 times 1.989. Remember our review. What it's basically saying, here's our boxed number, right? What would this be in comparison with 12.5? That's what they're really asking. Is this going to be greater or less than or equal to? Well, yeah, that's right. You just said this is bigger than 1. You are correct. Since it's bigger than 1, then this is going to be greater than our product, right? So, question, what side does this go on? The product is less than the box number. This is less, right? Less than this number. So we would put that in here. Okay, I shrank that down and put it in our box, right? That's our problem here. Okay, let's do this one. 8 to 8 times 0.921. What is it in comparison with this 8 to 8 number, right? Here's our comparison, right? Is this product going to be greater than this? Or is it going to be less than? That's right. This is going to be less than. Why is this less than that? Because this is less than 1, huh? So even though there's a 9 there, which is a bigger number, it's behind the decimal. So this is actually going to be less than 8 to 8. So where are we going to put that on our chart? Okay, so I shrank that down and put that into our box here. That's how you do these problems, okay? Okay, writing a statement using one of the following phrases to compare the value of the expressions and explain how you know. Okay, 14 times 0.99. 14 times 0.99. Is it going to be slightly more than 14? Is it going to be a lot more than 14? Is it going to be slightly less than 14? Or is it a lot less? Which one of these is it? Well, 0.99 is close to what? It's really close to 1 whole, isn't it? Really close. So would it be a lot smaller? No, it wouldn't be. What would it be? It would be slightly less. So I write in slightly less. Why is it slightly less? Because 0.99 is close to 1 whole. Right? Does that make sense? And that's the way you do these problems. Okay? Now this problem, 2,000 times 1 point. Wow. Is that slightly more, slightly less, a lot more? Which one is it? You need to fill that out in there. Now, if I said Rachel is 1.5 times as heavy as her cousin, Kayla, I could put R times 1.5 is what to K? R would be greater than K, right? But it says Jonathan weighs J times 1.25 then K. All right. Is J greater than K? Yes. Why? Because it has a 1, right? So my question is, who's heavier than who? Because that's what they're asking us to do. List the cousins from lightest to heaviest. Oh, lightest to heaviest. So who's the lightest one of them all? That's right, K is less than. Which one weighs more? Do you think R weighs more or J weighs more than R? Which one? Yes, that's right. 1.2 is smaller than 1.5, huh? So J would be here and weighs less than R. Do you see how that worked? Did we have to multiply anything? No, we didn't. What were we doing? We were just going by this number here, huh? It's pretty easy. It's scary at first, but it's pretty easy. Now let's do this one. A times B is greater than A. Okay? So I'm just going to do it down here just so we can see it. Okay? I'm going to push this up. Here's our problem. So let's just say I put a number in here. Let's say I put 1 as my A. So I could put a 1 under here too, right? Now if this is going to be greater, what would we have to multiply the 1 by to be greater than this? Yeah, good job. You guys, someone said 2. Nice work. Yeah, 1 times 2 is greater than 1, isn't it? So then we could say, well, B equals 2, right? Because we just gave it a value so that we could figure the problem, right? And that's the way you make up these. So we could say, for this statement to be true, B must be what? Greater than 1. Yes, greater than 1. So to do these problems, just plug in your numbers and it'll make it a lot easier for you, okay? All right. I love math.